Assalamualaikum, everyone. In today's lecture, we are going to cover the pre-stress model analysis. Okay, for this video, we have this geometry here, and there's this end is fixed board. Okay, and then we have applied a point 0.1 pounds per square inch pressure from the bottom surface. Okay, in the upward direction. Okay, this is the in this analysis, we are going to form how much what's the frequency, natural frequency of the system. Okay, so for this one, you see that I already have the folder, the model analysis tool at my desktop. Okay, this is my previous analysis, and I'm going to save the same geometry here. Okay, but for this time, I'm going to use this. I already have the geometry, and it's the IGES file, and previously it was the step file. So I'm going to import this IGES file and then how to do that. Okay, we'll see that. Okay, but as we are going to perform the piece test analysis, okay, so first of all uh, I'll have to evaluate the static structural results. Okay, so this is my, basically you see that this is the base analysis. Okay, so whatever the results I will get here, I will add those results into the model analysis. Okay, for this one, let me change the material to I want to make it titanium alloy. So just go there and how to add the material. Okay, this will also add an exercise to. Okay, normally the material is aluminum alloy, so I can change that to. Okay, so just make it to the aluminum alloy. So how we can do that? First, in the engineering data sources, okay, go to the general material category, and then here I will find the aluminium alloy. Where is that? Okay, just add that. Okay, if you see the book icon here in front of the aluminium alloy, so it means it has been added to our materials. Okay, that's fine. Just close it from here. Okay, to import the IGES file, so just right click here and then select the design modeler. Okay, so just wait there. Okay, so to import the geometry in design modeler, go to the file option, and then there's an option of import external geometry here. So just import external geometry file, and then so just go to your folder. Okay, where is that? Desktop model analysis 2. Okay, so I have placed the file here, so I will import this file into this folder. Okay, so for that, I will simplify the geometry, just like this option, yes, and the topology, and yes. Okay, so what basically it does, okay, the simplify geometry, if there are you see that there are problems, so what it does, okay, the simplified geometry, okay, it would basically remove the unnecessary material like holes, or you see that there are some bars, okay, which might affect which do not affect your results, so it can remove that. And simplifying topology, okay, it also you see that eliminates any, you see that there are two faces, okay, which are close to each other, and there is a very small gap, so it would basically merge those faces. Okay, and if there is any blur, then that can also remove. So just make sure that when you import the IGES file, so simplify geometry and topology, you need to check that. Okay, so now just generate that. Okay, so I have my geometry here, so just close that. Now start Ansys model. Okay, Ansys mechanical. It takes some time as usual. Okay, so just check that geometry is fine. Okay, and then go to the geometry, okay, and face, and assign the material to aluminum alloy. Okay, so that's here. Okay, that's fine. And then right click and then select generate mesh. Okay, I have my mesh here. Okay, so static structure, right click, insert, and fixed port. Select the face, select this face, apply. Okay, so I have my fixed face sport here, and now I need to basically see that insert, apply the pressure. Where is the pressure? Okay, let me check the unit. Okay, I will change that to use customary inches because that's pounds per square inch. So select the bottom face, apply the pressure to 0.1 pounds per square inch. What was the value? Okay, and then just let me check. Okay, it's fine, it's in upward direction, and then solve it. Okay, so Ansys has solved my model. Right click, and I can add the total deformation or the directional deformation. You can see there. Okay, but that won't affect my results. Okay, so I have my directional deformation here. I can add the stresses to. Okay, just say that equivalent one minus stresses, evaluate all results. Okay, so that's fine. Okay, so I have performed the static structural analysis. Now just close that. And then okay, I need to check where is the model analysis. Okay, just select the model analysis and then drag it to the solution till the solution. Okay, and then drag it here. Okay, now okay, so what the model analysis is doing, it's going getting the engineering data from here, geometry from here, the model from here, and all the way the results. Okay, the results of this static structural analysis are going to the model analysis and for the setup. Okay, and okay, so this is basically the base analysis, and this is you see that the model analysis. Okay, right now I have done these two separately, but if you go to the custom system, okay, you might find that okay, where is that? There's a pre-stress model analysis. Okay, so you can directly okay, just drag it here as well. Okay, so that's basically the combination of these two. Okay, so just click the setup here. Okay, I have okay in the model analysis setting, select the maximum modes to 7. Okay, that's fine. And then select the solution. Okay, and there's nothing else required because I have applied the fixed mode here. So just right click and then solve. Okay, it says that you have performed, just ignore that error. So now I have my all the natural frequencies here. So just right select all these, create structure mode shape, and then right click, evaluate all results. Okay, these are all my, you see that the natural frequency, and these are the mode shapes here. Okay, you see there. That's how we can done the perform the uh, you see the pre-stress analysis, and then you can check the participation vector somewhere here and effective mass, and then you see that extraction 0.8.1, so that's fine. So we have evaluated, you can see that the enough modes. Okay, 7 are fine. Another thing I want to show you is that okay, for that I had basically evaluated the stress value here. Okay, you see that these are the stress value from the static structure analysis. Just check the value. This is 346. Okay, okay, now I want to evaluate the stress value from here. Okay, so just I would clear the generated data here, and for your simplicity, okay, you see that I would just delete these as well. Okay, you can not the solution, just this. I would delete these deformations. You see there. Let's delete all of these. And now in this analysis setting, okay, I would go to the output control, select the stress value here. Okay, I want to calculate the stresses as well, and then you can see that strain as well. Okay, so now just solve the model again. Okay, so I have all these mode frequencies. Just right click, create model shape, and in addition to that, I will also evaluate the equivalent stresses. Okay, and then right click, evaluate all results. Okay, I can do that because I have already uh, told that you can say that the solver, okay, to calculate the stresses. If you haven't done that before, okay, then it would generate a warning error or the error. Okay, so now you see that okay, just compare that okay, the values of the equivalent stress from the model analysis. Okay, it's 4.3 into 10 is to power 6 psi, while for these are actual values are, you can say that 346. Okay, these are much lower value, and these values are too high. Okay, similarly, if you determine the you can say that the strain value, that would also be much higher. Okay, that's what it written here. Okay, because there are the large deformation in the structures, and we have run the analysis without like you can say that without checking like the large deformation may occur. Okay, that's turned off, so that's why you can say that, okay, the value of the stresses or the deformation from the model analysis are in. Last thing to add, that how to save this project, okay, similar to that for your on. Okay, so I have my model analysis here. Just save the project and select the desktop again. This is the model analysis too. Okay, so this is pre-stress model analysis. Okay, so I would keep the file there. Okay, just make sure that, okay, you have to perform it the same way. Okay, now you have okay, it will just take a second. Okay, now you can close that. Now I have my pre-stress model here, and then I have my result file here. So if I just double click here, I can reopen my reopen my analysis. Okay, that's it for today. Thank you so much. Thank you.